It's time for Maths with Mr. Thomas.
Yo ho ho! Here we are with chapter 13, lesson number 5, section formula. Woo! This is looking at dividing a line into a given ratio. Now, the last lesson we were looking at collinearity, and if 3 points are collinear, if they lie in a straight line, we can find the coordinates of one of the points if we know the coordinates of the other two, and the ratio into which the line has been divided. Now here we've got a line going from A to B, and we've also got this point P somewhere on the line. The points are collinear. There are the position vectors A, P and B. So A is the position vector going from the origin up to point A. B is the position vector going from the origin up to point B. And P is the position vector going from the origin up to point P. We are also told that P divides AB in the ratio m to n. So we've got m parts here and n parts here. What we've got to do with these questions is we have to find this point P. And to do that, we are going to be thinking about vectors. So let's say then that the vector from A to P and the vector from P to B, if we divide them, well, that's going to be the same as dividing m over n. This is a proof for the formula that we will come up with. You don't need to know this bit, it's just very quickly where it comes from. If we cross multiply here, we'd have n times AP equals m times PB. From there, we know the vector AP is going to be P minus A. PB is going to be B minus P. Multiplying out the brackets will give us this. If we move the terms with P in them to the left and move the terms with A and B to the right, we'll end up with that. On the left-hand side, we've got MP plus NP, so we can take out P as a common factor, getting down to that. And then from there, if you divide both sides by M plus N, you end up with this. And position vector P is given by N times position vector A plus M times position vector B over M plus N. Woo! And this here is known as the section formula. It is not given in the exam, so you do have to remember it. But I'll give you an easy way to remember it. So, note number 1. This diagram is very useful when using the section formula. So rather than memorizing n plus A over B over M over what? Well, what you think is just draw a straight line, whoop, put A and B at the top, put M and N on the bottom, and you've got a point P just in the middle. So this diagram helps you when it comes to memorizing the section formula. A couple of other things about the section formula. If point P divides AB internally, what it means is that P lies between A and B. If it divides internally in the ratio 3 to 2, what that means is going from A to P is 3 parts, and from P to B is 2 parts. So you will have something that looks like this. So going from A to P is 3 parts, and then going from P to B is 2 parts. So that is when it is divided internally. P lies in between A and B. However, what you also get is you are told sometimes that P divides AB externally. Woo! And that means P does not lie in between A and B. What it means is that going from A to P will be so many parts. So here we're told divides externally in the ratio 3 to 2. So there are 3 parts going from A to P. But because it's external, we don't keep on going for B. We will then go back the way towards A. And if we do that, then it means we are going back 2 units. So if we ever see it dividing externally in the ratio, for example, 3 to 2, we have to write that as 3 to negative 2, because we are then going to P and then going back the way towards A. The negative can go with either number, so you could write that as negative 3 to 2 or 3 to negative 2. It doesn't matter which number the negative goes with. Let's try some examples then. Example 1. AP to PB equals 2 to 5. i.e., what that really means is that P divides AB in the ratio 2 to 5. Find P given that A is 3, 4 and B is 17, 11. So to start this off with these questions, what I would do is just write down what I'm told. So I know that AP to PB equals the ratio 2 to 5. I also know the points A and I know the point B. Remember the section formula? This is it here. Either memorize the section formula or think about this wee diagram. So you've got A and B, M and N. If you think about the different points then, well, we know point A, we know point B, and we know the ratio it divides it in is 2 to 5. So we've got a 2 and a 5. If we take that then, we can say that position vector P will equal, well, you're really cross-multiplying over here. You're doing the 5 times the A and then the 2 times B. So we do 5 times position vector A, and the position vector A will be 3, 4. And then we're going to add on M times B, which is going to be 2 times 17, 11. And we're going to divide that by m plus n. So you're taking the two numbers in the ratio and adding them together. So it'll be the 2 plus the 5. From that then, you can multiply this vector by the scalar. So you will end up with 15, 20. Multiply this vector by 2 and you end up with 34, 22. And you are dividing that by 7. It's the 2 plus the 5. From there, just add the vectors at the top and we'd end up with 49, 42 over 7. Really, when we are dividing by 7th, we're really just multiplying the numbers by a 7th. So you could also just write 1 over 7 here. So it's a 7th of 49, 22. From there, divide the numbers m by 7, and we end up with 7, 6. That is the position vector for point P. So from the origin to get to P, you would have to go along 7, up 6. So really then, the coordinates would be 7, 6. And that would be your answer. Let's try another one. Example 2. P divides AB in the ratio of 3 to 2. Find P given that A is 2, negative 3, 4, and B is 12, 7, negative 1. So again, just start off writing down what you know. Well, you know the ratio. AP to PB is 3 to 2. And we know the points A and B. The section formula is this. I find this diagram helpful. So I've got A and B, M and N. And from there, you can just put in these values. So you've got A and B, you know those coordinates, and you know the ratio is 3 to 2. From there, I am going to be doing 2 times position vector A. So it's 2 times the 2, negative 3, 4. And I'm adding on 3 times position vector B. So it's going to be 3 times 12, 7, negative 1. I'm going to be dividing that by the two numbers in the ratio added together. So it's the 3 add 2. From that then, you can multiply this vector, multiply by the scalar, multiply by 2. Multiply this vector by 3, and that's what I would end up with. And obviously in the bottom, 3 add 2 is 5. From there, if you add the vectors together, add the x's, add the y's, add the z's, you're still dividing by 5. Or again, you're really taking a fifth of that vector. So you multiply every single term by 1/5, or divide by 5. You would end up with 8, 3, 1. Meaning then the position vector would be 8, 3, 1. You're wanting the coordinate then, so the x, the y, and the z coordinates would be 8, 3, 1. Make sure if it does ask you for a coordinate, you are leaving your answer as a coordinate. Let's try another one. Example 3. Find the coordinates of the point dividing the line joining E, 5, 2, 1, and F, 9, 10, 13. First of all, internally in the ratio 1 to 3, it's in bold because this is the page I will do the answer to this one on, and B externally in the ratio 1 to 3. So first of all, write down what you know. Well, we know the ratio from E to P, then P to F is going to be 1 to 3. We also know the points E and F. Again, the section formula is this. I find this diagram helps. Here though, I don't have A and B, I've got E and F. So that's the 2 points that I'm writing down, and the ratio is 1 to 3. So I'm writing that down. I'm then going to be doing 3 times position vector E. So it's 3 times the 5, 2, 1, plus 1 times position vector F. So it's going to be 1 times 9, 10, 13. And I'm dividing that by the sum of the two numbers in the ratio. From there, multiply the 5, the 2, and the 1 by 3. Multiply the 9, the 10, and the 13 by 1. And 3 add 1 will give me 4. From there, add the two vectors. So add the x's, add the y's, add the z's. I'm still dividing by 4, or really it's a quarter times that vector. If you multiply every single number by a quarter, or divide them by 4, you'd end up with 6, 4, 4. Meaning then that point P, I'm just going to call it point P, that will have the coordinates 6, 4, 4. Woo! Let's try the next one then. This time though, it's asking for the point dividing externally in the ratio 1 to 3. So remember, if it's external in the ratio 1 to 3, it means you're going along one part, but then you're going back 3 parts. So here, your ratio will be given as -1 to 3, or 1 to -3. It doesn't matter which number you put the negative with, as long as when it's external you put the negative with one of those numbers. The 2 points, they're still E and F, we've still got them down, and again this is the section formula. I find this diagram helps with A and B and M and N. So the 2 coordinates A and B, well that's just E and F. This time instead of point P, I've already used point P just in the last example for part A, so I'm going to call it point Q this time. The ratio is -1 to 3, just make sure you are doing that if it's external. So you would have -1 to 3. From there then, I'm doing 3 times position vector E, so it's 3 times 5, 2, 1. Take away, because it's -1 times position vector F, so it's -1 times that, 9, 10, 13. And again, I'm dividing that by the sum of the 2 numbers in the ratio, so -1 plus 3. If you work that out then, so 3 times 5, 3 times 2, 3 times 1, and then 1 times 9, 10, and 13, and you're subtracting the vectors this time. Subtract them, you would end up with 6, -4, -10. And again, you're still dividing by 2, or multiplying by half. From there then, if you work that out, you'd get 3, -2, -5. Meaning then, that point Q, I'm calling it, remember I used point P in the A, so I'm going to use point Q here. So Q would have the coordinates 3, -2, -5. Next example. Example 4. Triangle ABC has vertices A, 3, 0, 6, B, 0, 3, -3, and C, 1, 0, -4. P divides AB in the ratio 1 to 2. Q is the midpoint of AC, and R divides BC externally, woo, in the ratio 2 to 1. Find the coordinates of P, Q, and R. Man, that's a long question. So for this, first of all, working out the coordinates of point P, well, we are told that P divides AB in the ratio 1 to 2. So first of all, we know AP to PB is going to be 1 to 2. We know the coordinates of A and B, so just write them down. And again, we are going to be thinking section formula. P is dividing this line AB into that given ratio. So there is your section formula, and there's your diagram that may help you. So we've got the 2 coordinates, A and B, and we've got the ratio M to N, or 1 to 2. Swapping them then, we know A and B, we know the points, and we know the ratio is 1 to 2. From there then, if we're crossing over, we know 2 times position vector A, so it's 2 times 3, 0, 6, plus 1 times position vector B, so 1 times 0, 3, -3, and we're dividing that by the sum of the 2 numbers in the ratio, so 1 plus 2. From there, 2 times 3, 2 times 0, 2 times 6, 1 times 0, 1 times 3, 1 times -3 will give us these 2 vectors. We're still dividing by, well, that gives us 3. From there, add the vectors together, we get 6, 3, 9, and we're dividing by 3, or multiplying by 1/3. Multiply each of the numbers by 1/3, or divide them by 3, will give us 2, 1, 3. So that is position vector P. We are asked for the coordinates though of P, so the coordinates would be 2, 1, 3! Woo! And that is your answer. Moving on to the next part. Find the coordinates of P, Q, and R, so find the coordinates of Q. Well, what are we told about Q? Well, we're told Q is the midpoint of AC. So we know these 2 points and we want to find the midpoint. How would we do that, Sahana? Midpoint formula! Brilliant! So thinking about the midpoint formula, that is where you would add the x's, add the y's, add the z's, and you're dividing each of them by 2. So add the x's, divide by 2, 3 add 1, divide by 2, 0 add 0, divide by 2, and 6 add -4, divide by 2. That'll give us 4 over 2, 0 over 2, and 2 over 2, meaning then we'd have 2, 0, 1. So Q would have the coordinates 2, 0, 1. Simple as that. R. Find the coordinates of R. Well, what are we told about R? Well, we're told R divides BC externally in the ratio 2 to 1. So here, because it's external, we know that one of the numbers will have to be a negative. So we can say then that BR to RC is going to be, put the negative with either of the numbers, doesn't matter which one, normally just put it with the smaller of the two, and so you would have 2 to negative 1. The 2 points, well, we've divided BC, so we have B and C. Thinking about the section formula then, that is your section formula. That is the diagram that may help you. You've got the 2 points, you've got the ratio at the bottom, and we are thinking about those coordinates. We've got B and C this time. We've got this point R, so we're putting an R here, and the numbers for the ratio, we'd have 2 and a negative 1, or negative 2 to 1. Doesn't matter which way you do it, you'll get the same answer. From here then, working out position vector R, well, it's going to be negative 1 times position vector B, so negative 1 times 0, 3, negative 3, plus 2 times position vector C, so 2 times 1, 0, and negative 4. We're dividing that by 2 plus negative 1. That'll then give us negative 1 times 0, negative 1 times 3, negative 1 times negative 3, 2 times 1, 2 times 0, 2 times negative 4, and we're dividing that by 1. 2 plus negative 1 is 1. From there, add the vectors together. We're still dividing by 1. Really, when we're dividing by 1, we're multiplying by 1. It's just staying exactly as it is then. So we'd have 2, negative 3, negative 5. Meaning then that R would have the coordinates 2, negative 3, negative 5. And that is your answer. Give these questions a shot. They are in the Maths in Action Higher, page 205, exercise 6. Check your answers as you go. Good luck. Woo! Bye.